Hi everyone, and welcome to question number 4 in Cape Pure Mathematics Unit 1 Paper 2 2019. This is a continuation of a series of past paper solutions for 2019 Cape Pure Mathematics. So let's get right into it. So number 4 asks what deals with circles. We start off with a circle and a straight line question. So it says a circle with equation x squared plus y squared minus 2x minus 4y minus 5 is 0. It has a center C. A straight line with equation y is equal to 2x plus 5 intersects the circle at 2 points A and B, and we are to determine the coordinates of C, or the coordinates of the center of the circle. It always helps to draw a diagram. So let's try to draw something. So that's my horrible circle. It's a center C. And it says that we have a straight line. The straight line doesn't necessarily have to pass through the center of the circle. The question didn't say that. So we would assume that it doesn't, and these 2 points are A and B respectively. So we are to determine the coordinates of the center. So let's just write the equation of the circle. So it is x squared plus y squared minus 2x minus 4y minus 5 is equal to 0. So the general form for the equation of a circle is x minus, let's say, a to be squared plus y minus b to be squared is equal to r squared. And of course, this here is your center, circle center. That's your x value. This is your y value of your coordinates. So your coordinates for the center would be a comma b. And this r squared, well, the r is for radius. So your radius r is whatever the root is of this expression. Well, let me just rewrite that. So you could say radius r. Alright, so if we have our circle in this form, we could immediately pick out the center. Well, in this case, they said they want the center C, so it's called C. So that's the center C. Let's see if we could, so there are two ways you could do this. You could expand out this expression and then compare coefficients with this. That may take a while. There is a shortcut way, which is what I am interested in doing. So let's see how that goes. So let me first rewrite this expression. We could call this equation 1. I am going to group all the x's and I'm going to group all the y's together. So I would say x squared minus 2x plus y squared minus 4y minus 5 is equal to 0. Now, let me just have a look at this expression. So I have x squared minus 2x and I have y squared minus 4. You know what, this x squared minus 2x, it looks like a square. So if you have a square, quadratic, if I had x squared minus 2x plus 1, then that, you know that if you have to factorize that, you will get x minus 1 squared. you know, and so this really matches this expression here, but of course I don't have the 1, so the 1 is missing. And then I notice y squared minus 4y plus 4, well, that happens to be y minus 2 to be squared. All right, so I notice that this expression is this expression here, but I'm just missing this 4. So that's what I'm missing. So I'm missing the 4 and the 1. And if they happen to be in the expression, then I could make this expression a square. But that's okay. I could add it in. So all I have to do is, so if I need x squared minus 2x and I need a minus 1, then I could stick in a minus 1 and I'll just plus 1 right after. So by me sticking in this minus 1 and then plusing 1 after, I'm really just adding 0. I'm not changing the expression. And then I would have plus y squared minus 4y, and I want a plus 4. That's great. That's plus 4 minus 4, and then I would say minus 5. That minus 5 comes in 0. All right, this is a 4 here. So notice I have minus 1 plus 1, so that's 0. I didn't change the equation, I just added 0. And this 4 minus 4 here is the same thing, that's 0. But I could now separate it. So I know that x squared minus 2x minus 1 could be written as x minus 1 to be squared. So this here is x minus 1 to be squared. Then I have a plus 1 remaining, that's okay. Then this expression here becomes y minus 2 to be squared. I have that minus 4 remaining. And then I got this minus 5. So this is great. This is great because I now completed the square. So let me just add up these constants. So this would be x minus 1 to be squared. I'm going to write plus y minus 2 to be squared. I have a plus 1, and this would give me minus 9. So 1 minus 9 is minus 8. So therefore, my circle center, that's RE, is 1, 2, x value and my y value, and radius root 8. Okay. All right, so I notice a slight mistake here. When I said this square is x squared minus 2x minus 1, this actually supposed to be plus 1, right? So it's x minus 1 to be squared, so this has to be a plus. That's a plus there, so this would mean that this is a negative. The working remains the same, it's just I made a very silly mistake with this plus sign and the negative sign. Right, so this is a plus, so that makes that a minus. So this means that I would have a minus sign here. So instead of minus 8, this would now be minus 10. So my radius is root of 10. Oh, that's horrible. Let me just erase that. Okay, root of 10. And all that is because I made this mistake with this minus sign. That's supposed to be a plus. My apologies. Okay, so I could say that we were able to prove the expression. Well, not really prove, but determine the coordinates of C. So now we could move on. So the question now says, show that the coordinates A and B are given by this expression and that BC is perpendicular to AC. Well, we have our diagram already on the top here. So we have the coordinates for C. We just need to find A and B. And they gave us the equation of the line that contains A and B. It's y is equal to 2x plus 5. So this is a straight simultaneous equation where we're going to have to substitute. So the equation is y is equal to 2x plus 5. And of course the equation of the circle, well, let's use this form here, the simplified form, x minus 1 to be squared plus y minus 2 to be squared, and we'll keep the 10 on the other side. So I have two equations, 1 and 2. So if I have to find the coordinates of A and B, or show the coordinates of A and B as 0, 5 and minus 2, minus 1, then I must make this substitution, or I must substitute equation 1 into equation 2, which is the easier to do. Alright, so there's a substitution for y, so I'll substitute y inside, y from equation 1 into equation 2, and I will solve for x. I more than likely will get a quadratic in x. In fact, I will get a quadratic in x, and that will yield to x solution, and then I will get the corresponding to y solutions. So let's see what this looks like when I put it in. So I would say substituting equation 1 into equation 2. So that would give me x minus 1 to be squared plus y is 2x plus 5, and that's a minus 2 to be squared is 10. So just simplify it as x minus 1 to be squared plus, when you work out inside these brackets, you should get 2x plus 3 to be squared is equal to 10. Let's expand our brackets. So this would give me here x squared minus 2x plus 1 plus 4x squared. This will give me 12 plus 9 is 10. Okay, so let's simplify the x squared. So this is 5x squared. Then I have a minus 2 and a plus 12, which will give me 10. And I have a plus 1 and a 9, which is 10. That's excellent, because I know I have a 10 on the other side. So the 10s will cancel. So this leaves me with 5x squared plus 10x is equal to 0. So if you factorize out 5x over here, you're going to get x plus 2 is 0. So therefore your solutions are x is equal to minus 2 and x is equal to 0. Alright, so those are my x values. So I would say let's find the corresponding y values. So when x is minus 2, we substitute into equation 1. That's the easier one to substitute into. So when x is minus 2, you're going to get y is 2 by minus 2 plus 5. Oh, I didn't need a bracket there. So y is equal to 1. So when x is minus 2, y is 1. That's one of the points. And when x is equal to 0, well, this should be easy. Y is equal to 5. So your other point is 0, 5. Right? So we just showed that A and B, the coordinates of A and B are 0, 5. So this would be A. And this would be B. And that BC is perpendicular to AC. Alright, so we have to show that BC is perpendicular to AC. So how do we do that? Well, we have to use gradients. So for EC to be perpendicular to BC, the gradient of AC M1 and the gradient of BC, let's call it M2, satisfy I'm running out of space, so let me see if I could just shift over a little bit. Right. The relationship that M1 is equal, sorry, M1 by M2 is minus 1. So if the gradient of AC is M1 and the gradient of BC is M2, then M1 by M2 had to be minus 1 for them to be perpendicular. So we need to find these gradients. Well, that's easy. So just let's write the equations. Let's remind ourselves what the coordinates are. So A is the point 0, 5. C is the point 1, 2. And B is the point minus 2, 1. So I said M1, which is the gradient of AC, is 2 minus 5. So that is 2 minus 5 over 1 minus 0, which is minus 3. And m2, which is the gradient of BC. So I probably skipped a step here and didn't label my, so let's say this is, you have to write x1, y1, x2, y2. So I skipped these steps, but let me at least do it over here. So your gradient m2 is y2 minus y1 all over x2 minus x1. So m2 is 2 minus 1 all over 1 minus 2. So that would give me 1 over 3. So m1 by m2 is minus 3, multiply by a third, and that gives me minus 1. So I satisfy this condition. So therefore AC is perpendicular to BC. Right? So we were able to show that. So part 3 says determine the equation of the tangent to the circle at either point A or point B. So we want the equation of the tangent for the circle. So let's look at point A. So I would like to use point A. Why do I want to use point A? Well, mainly because point A has a 0. And zeros are very nice to work with. So I will be using point A. So they say determine the equation of the tangent to the circle at point E. So point E, now we just proved that AB. So let us draw something. I mean, it's better to see it if we draw. So we have a circle, center C, and this is the line AB. So if I were to draw a line through here, then they want the tangent to the circle at point E. So if I were to try my best to draw a tangent, and this tangent would be 90 degrees to there. So this is E. So I want the equation to this tangent. So my first question is, I have A. What is the gradient of this line? Well, thankfully, I have the gradient of AC already. And this line is 90 degrees to AC. So the gradient for AC, which we have already, is actually minus 3. So remember, we found the gradient for AC to be minus 3. So the gradient of AC is minus 3. Then the gradient of the tangent at E is equal to a third. How did I get that? Because they are 90 degrees. Because this gradient multiplied by a third must give me minus 1. So that's this formula that we use there. Right, so I know the gradient and I know a point, then I could find the equation of the line. So we will be using y minus y1 is m into x minus x1. So that's why I'm using 0, 5. So this will just be y minus 5 is equal to a third into x, because x1 is 0. So that gives me y is equal to x on 3 plus 5 as my answer. Okay. All right, let's move on. So we're moving now on to vectors. So the question goes, we have a point P, Q, and R, and there are 3 vectors in a parallelogram, P, Q, R, S. And we need to express vectors P and Q in this particular form. Again, let us draw something, and probably it'll be better to visualize by drawing. So the parallelogram should look like something like this. Oh, it's looking more, oh, this is a horrible parallelogram, but that's fine. So we'll say P, Q, R, S. This is normally the convention when you label your diagram. You go in a anti-clockwise direction, so it's P, Q, R, S. Yeah, so now that we have able to visualize the parallelogram, let's find PQ. So PQ is in fact vector PQ is in fact OQ minus OP. Okay. So we know that OQ, I like to write my vectors like this. It's easy for me to perform any manipulation of the vectors when you write it as a column. And then my OP is 3 minus 1, 2. So when I subtract, this is minus 2, this is 3 minus 6. And if you wanted to write it in that form, well, it's minus 2i plus 3g minus 6k. But it's better to write it in this form. It's easy for you to perform the matrix operation. So that's PQ. So they want QR as well. So let's say QR. So QR is OR minus OQ. OR is minus 1, 1 minus 2. And OQ is 1, 2, minus 4. So this will leave me with minus 2, minus 1, and this here would be 2. So if I have to write it in the form that they wanted, minus 2i minus g plus 2k. Okay, so we express PQ and QR in that form. So part 2 says, show that vector S is perpendicular to the plane through P, Q, and R. So if you have a plane, and this plane has P, Q, and R, then what that says is that vector PQ and QR lie on the plane. because if the points P, Q, and R lie on the plane, then P, Q, and QR will lie on the plane also. And we say that this vector is perpendicular to the plane. So if this vector S is perpendicular to the plane, then S is perpendicular to both PQ and QR. What this means mathematically is that PQ dot OS 0 and QR dot OS is also 0. So we now have to show that by using the dot product, which is very easy. So I just need to find out or remind myself what PQ is. So PQ is minus 2 minus 236 dot OS, which is 0, there's no item, minus 16 and then minus 8. So when you dot this, you get these first two terms here, you get 0 plus 3 by minus 16 plus 6 by minus 8 and this will give you 0. Right? And for QR, QR is minus 2, minus 1, minus 2, sorry, plus 2. Let me erase that. And OS 0, minus 16, minus 8. So let's find the dot of this. So that is minus, that's 0, plus 1 by 16, minus signs will go away, minus 2 by 8. Of course this is 0. Alright, so we could say therefore OS is perpendicular to a plane containing PQ and R. Right, so that wasn't too bad. So let's move on. And you know what? They want us to find the equation of the plane. So they say determine the Cartesian equation of the plane through P, Q, and R. So the equation of a plane, there are multiple forms you could use. I am using this form. N dot R is equal to N dot R naught. And here is the vector perpendicular to the plane. And R naught is a point or it's a point in the plane or vector in the plane. So luckily, the question above asked me to show that OS is perpendicular to PQ and R. So I already have end, and then I have R0. So my end is OS, which is equal to 0 minus 16 minus 8, and R0 I'm using as minus 1, 1, and minus 2. Okay, so this R0 is, oops, sorry about that. Let me just find my way back. That's the point R. So I'm just using the point R, which is in the plane. So this is really OR. Okay. So the equation of the plane is now 0 minus 16 minus 8 dot x, y, z is equal to 0 minus 16 minus 8, and then I have this point that is R, which is minus 1, 1 minus 2. So when you simplify, I don't get a value on x because you have 0 multiplied by x, so I just get minus 16y. Oh, there. Let me just erase that. I don't know where this came from. Yeah. Oh, sorry about that. Yeah, so hopefully you will still be able to see this. Good. So you would get x by 0, which is 0, so you got minus 16y minus 8z is equal to that 0, and you will get 0 here. So the equation that you would be, when you simplify, you're going to get is minus 2y. You just divide in by 8. Minus z is equal to 0, or you could just, I should have taken out the negative sign, so 2y plus z is 0. So that's the equation of your plane. Okay, so thank you for listening. I apologize for the mistakes. Look out for question 5 soon. Bye.